Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about Edge AI. So let's dive deep into it. So basically, what is the problem that we need Edge AI? The problem is that we want AI in many things at this point in time. We want AI in every Tom, Dick and Harry. So why don't we do that? Well, there is a problem known as sensitivity, meaning there are different things or different classifications that have different type of sensitivity. For example, some things are latency sensitive, meaning you cannot afford the luxury of like, okay, let me call the home center or let me call the mothership or something like that. Yeah, no, that's just like, no, you are too sensitive for that in terms of latency. Another is security sensitive. For example, if Ukraine is making an AI drone that is gonna go find the bomber and go kaboom on it, they do not have the luxury of sending that data anywhere else. And if you ever wondered why the heck Russians have so many rubber tires on the wings, that was to confuse the image generation AI. And I'm pretty sure it did work at the early phases, but then they refined it. So security sensitive, I'm pretty sure you can understand, like there are certain things that has to be done on system. You cannot rely on basically transmission. Then we have privacy sensitive thing. For example, assuming you are not stupid, assuming you understand human nature, you will know for a fact that if everybody can have a copy of audio that you are speaking 24/7 in your household, they can stitch it up or use it to blackmail you or to send you to jail. Yes, those sort of things can be done and has been done. So you may be like, hey, I do not like the idea of having Alexa in my home that is listening to me 24/7 into 365. So you may be like, okay, but I still like the convenience. How about I have something that is local, which is not transmitting the data? So fundamentally, there are a lot of practical reasons of privacy. And then you have safety sensitive system. For example, what if it's a hospital system? It cannot glitch out. It cannot just like, oops, like it does not have the luxury of like, oh, the network is down or the port forwarding is not working or somebody uploaded a bad update. Yeah. So critical systems are like, yeah, no. So there are genuine reasons. We want AI. It's just that there are certain limitations which limits us, like, that calling to the home base is not a wise idea. So what's the logic behind it? Well, first you have to understand, whenever you are generally talking about AI, you are talking about this puppy. What are these puppy? This puppy is what we call neural network. What is this? This is just parameters. Now here's the deal. How the heck these parameters become something that resembles intelligence? We tune it. Basically, if you just have a random value, you're gonna get a noise out of it. So it takes lot of horsepower. I mean, bonkersly, idiotically large amount of data to get something useful out of it. And you have to crunch that. And that crunching requires gigawatts of power, bonkers amounts of data server. So if you are seeing people are building huge hyper clusters, what are they doing? They are training this. What does training mean? Training simply means each node have certain values or parameters, so to say, that has to be tuned to get the desired result. And that takes time, compute, and money like there is no tomorrow. Meaning, if you have to ask how much this cost, you can't afford it. So, and again, billion parameters, like, we started with that. Now we are reaching trillion parameters. So yeah, bonkersly large amount of horsepower is needed to create a brain on silicon. However, let that be very clear, making this puppy is very inefficient. Basically, we are turbocharging evolution. But the moment you are going into inference, basically you made the brain, now you copy paste it into system silicon. It's surprisingly efficient. Why? Because it's working on inference mode. Inference does not require the same horsepower. And if you train this puppy and optimize it, it does not require, like, it could be working on 1,000th of a horsepower that was required to run it on a large server system. So it is practically possible that training requires energy, compute, like there is no tomorrow. But running it inference-wise, that can be done on your SoC with basically few watts of power. That can be done. That has been done. And again, it was very difficult in early 2020, but by 2025 is like the computers have dedicated hardware that's like, I got you, fam, I got you. So fundamentally, the improvement in SoC that makes this idea of practical reality, not just like it could be done with very limited hardware. No. It's like we can do this, like actually do this. At this point in time, you must have paid attention to the fact that computers have now the third term. We used to have CPU, GPU, now we have NPU, neural processing unit. That puppy is fine-tuned and optimized to run this puppy as efficiently as possible. Meaning, for per watt of computation, you can do things that 5 years ago was like, are you serious that you can even do that in 1 watt of power? Now it's like, bruh, we got this, we good. So that is possible. And how do we measure it? We generally measure it with tokens as a per second per watt. Yeah, it is a complex unit, but we are getting good, like genuinely good. and more things can be done at the edge. Now let that be very clear, it does have certain limitation. You can have higher quality edge, but if you have like a Raspberry Pi, you can run AI, it's just gonna be slow. You can run a NVIDIA Nano, that will be much better, but again still would be limited. And then you can run like some MacBook or high-end system or framework system where there's like 192 gigabytes of VRAM, because then you can load all of this into the RAM memory and crunch through it very quickly. Yeah, you can get some genuinely high horsepower thing output of it. So more things can be done on edge now than it was even imaginable 5 years ago. Like, we are going through accelerated timeline. So the first customer of this technology is IoT, Internet of Things. Now, Internet of Things is a kind of weird term. The original idea was things were making their own internet. For example, if you have a factory, factories require boatload of sensors to do preventive maintenance, and you have lots of sensors over there. And again, all of them will create their own network. So internet. But here's the deal. The idea that it has to go to internet in order to like go to some Amazon web servers or some sort of a data cluster and all that, that was not desired. Like, it can be done, and some scenarios, especially in terms of data logging, it was desirable, but it was not, it has to do this. That was not a good idea. And again, people learned it the hard way. So local network, GG. Everything is working on local network, awesome, GG. But if you have to transmit every single thing, that is just too problematic. Because here's the deal, even if you have a factory, right, and factory has every sensor that needs to SCADA system and all that jazz, that is transmitting data over secure protocol, cool, awesome. But here's the deal, what happens if your network goes down? Like, again, earthquake, flooding, tsunami, hurricane, or even like, okay, what if I have satellite? Again, those also do go down. Few days ago, Starlink went down. Not because the hardware went kaput, simply because somebody uploaded bad code, and things like that does happen. So it creates a scenario. And penalty of that is that it increases power usage, meaning a sensor that is only transmitting data to locally, the total energy consumption of the whole ecosystem is very little. Like, you have a node that receives it, done, processes it, done. That's like few watts. But if you have like a node that connects everything, compiles it, and then transmits it, now that's a multiple kilowatts of power consumption per day. So power draw also goes up. Again, thousands of sensor. You're like, okay, that's a small data point. Now you need a freaking server rack that is collecting all the data, processing all of it, and then transfer it. And again, it's a high priority system, so you will have dual network dump. So overall, it creates two major vulnerability. First, security vulnerability. No network is impenetrable. It's just the best network that cannot be hacked is the network that is not connected. That's why we have CCTV. Close the circuit. It's not connected to the outside, it cannot be hacked. So close circuit. And dependency. Again, you are dependent on the service provider if they are doing the job right or not. So fundamentally, at this point in time, the current hardware that is available in 2025 and the wisdom of improving the LLMs and neural processing units, you can do a lot of tasks locally and fast. Meaning, it's wabam, like you can run the whole system, and AIs are at this point in time so good that if you have a computer box, like industrial computer box like this can not only just work like a system, green or red, it can detect off situations. Meaning, if something is getting off kilter, it can detect it. Again, data has this unique property. For example, if I give you 1 truck's data over a month, it does not mean anything. I give you 100 trucks data over a course of a few months, you can easily figure out which truck is about to go bad simply because it's a data point. Like, let's say all the fuel consumption data line is like this, and one data line is kaput like this, you'll know, okay, that truck is broken. So that's why once you have that sort of data crunching on site, you get exposed to a higher level of sensitivity where you're like, no, this motor is about to go kaput, and it's like 5 minutes later the motor went kaput. So things can be done, like things you cannot even imagine is now possible because edge AI is actually that good. The horsepower is there, the improvement in the neural models are there, and the fact that sensors are rather simple. We are sorted, like you have temperature sensor, pressure sensor, theft sensor, level sensor, proximity sensor, humidity sensor, security sensor, gas sensors, infrared sensor, vibration sensor. Yeah, these things are done. Like we good, we got this. This is done. Even with your home AI, you can literally nowadays, if you want to, you can have a AI system that controls everything in your household without exposing any of it to the internet, and you can still talk to it. You can talk to it. There will be a voice AI that can take almost Alexa level. And again, we are a bit far away, but it can be done where it's like you have refinement, meaning as the more you use it, the better it becomes. That part is difficult to do, but not impossible. And I'm reasonably sure that's maybe 3 years away, where you can have a closed circuit AI that in terms of your voice recognition will be like, because the more you use it, the better its algorithms will become. And it's like, yeah, I got you, fam. What do you mean to say I got you? So Internet of Things are making a very extensive use of this thing for household applications and industrial scenarios. So Edge AI is the money-making thing right now. We got the AI part sorted. Now making money from it. So IoT is the first thing. Then we come to Autopilot. Now, autopilots are what we classify as time critical. You do not have the luxury of like, okay, I'm driving it. Even at 60 kilometers per hour, you do not have the luxury. Let me call the home base. Yeah, that's like, no. So fundamentally, it's what we call very time critical and low tolerance, meaning recently we have been going through some rough patch during aviation era. Way too many accidents happen. But here's the deal. Take all of that. That's like 1 day of car accidents. So fundamentally, in terms of tolerance, car do not tolerate. Car is like, nah, bro, you have to be right every time. So oops is lethal here, meaning not only for occupants, but also for bystander, because more than enough people, I'm pretty sure it's at this point in time, more than 100 Tesla people went kaput. And there was a scenario that was very popular because a company was testing it. The driver went down to do something and they ran over a person. But again, Volvo was like, bro, our car could easily detect it. It has infrared cameras. Then they're like, oh, they disconnected that system to test their own system. So understand this, like this is genuine life or death scenario. You do not have the luxury. Everything has to be done on hardware itself. So calling to the server via network is just like, no. So people are like, we need 6G for this. No, no. Law of physics does not change and light speed does not change. So the answer is no. Anybody sells you that, run. And fundamentally, all driving related tasks, let that be very clear. What about navigation or your entertainment? That can happen. That's not an issue. But driving related, I mean, clutch, brake, accelerator, and steering input and indicators, those puppies have to be done on hardware itself. And over the air updates can be done, meaning your car is parked, you can have update and you can have upload. For example, when you are talking about Teslas, generally once they actually park for the night, they start to dump data. And let's say the place that you are using, they create a rudimentary optical map of it. That optical maps goes into basically a super cluster. Now here's the deal. Multiple cars in same area is doing that. So they are creating a layered map, because again, they do not have LiDAR. So precision is very sloppy. But again, if you have like 50, 60, 70 cars going through there and overlapping all the data, now you have a very high fidelity, high precision, real world data. That data is so high end that from a car's point of view, it cannot tell the difference whether it's running in real life or a simulation. It's like, okay, now they run their AI agents that are doing the training. So that can be done, no problem with that. However, it's something that you can have an add-on, not as a compulsory system. You know, not like, okay, we need 6G networking so we can talk to each other cars. I'm genuinely shocked. Way too many people are talking, oh, we need 6G or 5G for this reason, where we can communicate with other car. Do you drive with communicating with other car? No, that could be add-on. I could easily see that as a desirable thing, whereas like a police car can have a local area screaming, so to say, again in RF, where it is screaming police, 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 police. So all other cars that are like, you know, not stupid, they're like, okay, let me park away. Ambulance, 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 something there, like almost like a siren, but electronically working, and we will not even notice it. We're just like sleeping in the car or having love-making session in the car. Way too reason popular right now. So you're doing it that, you're busy with that, and cars is just like letting police go and letting ambulance go. That's a cool thing, but not like, okay, we need to call the home base. Nah, that's not. Now here's the deal. How much horsepower we are talking about when we are talking about like driving and all that? Ironically, if the model is refined enough, not a lot. For example, this is comma X3, I think. And this puppy has a hardware of 10 years ago. Note 9 kind of hardware, and they're running a car system. And again, how efficient this is, it's same level as Tesla. Now let that be varied. That's because Tesla is stupid. Now Tesla in every other car company is like, hey, let's not smoke, let's put LiDAR. Now like, why LiDAR matters so much more compared to optical system? We hallucinate. We have billion years of evolution and we still hallucinate with these puppies, and you're putting that there. And LiDAR is the absolute data. When LiDAR tells you that puppy is like 25 centimeters away, it's freaking 25 centimeters away. You will not have that Tesla system where it's like a truck was flipped over. The optical system is like, it does not tell you data. It has to compute. Computation could not figure out, because again, the trailer was flipped out. There's like, wabam. LiDAR is like, nah, bruh, there is a wall there. Stop. Like, I do not know what the wall is, but there is a wall that I cannot go through. Stop. So that's why LiDAR systems are far more efficient and safer. And this system is just hijacking the car's lane keeping functions and basically upgraded lane keeping function. So, is this logical solution? Ironically, yes. And I like the idea that there are some people who are like, what if we made the self-driving system? You're putting your life in the hands of Elon Musk or Tesla, which again, Tesla was planning to put LiDARs there, and then they removed it. Now they're like, okay, what if I remove the radar also? I'm like, yeah, remove everything that does not hallucinate and then put everything that does hallucinate. It's like, so I'm cool with that. And again, it does work. People have using it, and it's like, what? It's good. And the hopefully, the future idea is that you can, of course, this is early stage, getting the show on the road kind of scenario. The upgraded variant would be you'll have a computer box on the back, which is designed for high vibration environment, and it will be very specifically made in such a way that it can adapt. We have not done that yet. Meaning, if you are driving, like same way, this thing sends the data into the mother box, and the mother box does the computing and then trains all other the children. Imagine doing that on the car itself, like same way we humans do. Basically, you would drive the same road again and again, you figure things out. If that can be done, then I can see AI happening in India also, like realistically. Like we have animals running in the roads, car will be like, I got you, fam, I got you, I got you. And it's like a rain happening and road become not visible. It's like, okay, let's apply caution. It can do that. Again, as long as it can learn and adapt, it can actually be done even in Africa. So Autopilot is a serious scenario where without edge AI, it's not happening. So now we come to the dangerous part, drones. Now warfare has changed. Flat out, Russia-Ukraine want turbocharged drone warfare. And at this point in time, we have entered the era of drones, meaning pilots and all that jazz, they are like almost at the last leg, so to say. So land, air, sea, all of them, including underwater. For some reason, narco submarines also. All of them are at a drone level, meaning not only they are capable to be remotely driven, they can also auto-guide themselves. So yeah, now here's the deal. Why do you need AI on a drone? Well, if you do not have that, you have what we classify as remote control. Remote control has a range limitation. Even with a battery powered system, you can go very far. It's just that you can't carry that much optical fiber. And again, that optical fiber will become the drag point. And if you have wireless transmission, that can be blocked. So fundamentally, it creates a scenario where it's like, it has to be AI based. And these puppies, be it water, be it land, be it air, these puppies do require very strict power budget management. Meaning, if this puppy have battery, which again, it will have big bonkers battery, if the big bonkers battery should go into the propulsion motor, not the computation hardware for that propulsion motor. So power constraint is tight. Even on this, like, it's a boat, you can have 10 kilowatt of computer. No, you can't. Because if it is burning the fuel, it has a limited amount of fuel tank. It cannot just burn the fuel tank so it can power the basically computer, because that will reduce the effective range of it and top speed also. So fundamentally, whenever you are talking about this sort of thing, the power budget is tight. It's very tight. So again, that's why NVIDIA Nano 2 has been used. And humanoid bots, basically, whenever you are saying again, I am genuinely shocked and I'm like pressing X for doubt, is that China just claims that they have a humanoid bot, almost the same level as Boston Dynamic, for $6,000. That is humanoid, straight knees. Yeah, I'm like pressing X for doubt. But assuming, knock on wood, that is true, that thing will also require a bonkersly high-end edge device for computation of the AI, because without that, it can't work. Like, okay, what if I have a server closet or something like that? Still won't work because it needs to learn and adapt very quickly. For that reason, its motors need a very low latency communication between what LLM is figuring out versus what the actual gravity of the situation requires. So humanoid bot won't be very productive. Right now we have like arms and robots and all that, but to have a humanoid system that can do things and communicate, that does require seriously high level edge AI. However, all this thing sort of done, more or less done on construction, whatever have you. But the most dangerous part is that it is a very dangerous line to cross to give AI kill switch of human. And we did that past years ago. That's the part that scares me, because again, even if you're talking about drone warfare, when it started with a war on terror, it was still a person that was pulling the trigger. And like, okay, it does not make a difference, it's a screen. No, it matters. That person knows that I am poofing a person. The person knows that there is a person. But when you're talking about AI, and again, if you've seen that Russia having rubber tires on the plane wings, it was for that reason. They figured it out that Ukraine is utilizing AI, not just dumb drones. So they wanted to make sure to hallucinate the basically image recognition. So they put tires there. Again, I'm pretty sure it would have worked somewhere, early days at least. Now I'm pretty sure drone can go 3D analysis mode, and then it's like, nah, I see you, I boom you. But again, we did that. Like, that's the part. Like, we have given humans a kill switch to AI, and that's past tense. We did that. That's a dangerous part. That's again, there is a very awesome gentleman known as Godfather of AI who has even got a Nobel Prize for that. And he's like, the most scary part of it is that a large nation can now just steamroll a smaller nation and never have to worry about it. It's like, why? Well, you can just send the drones with some extra drones, with some more drones. And again, let's say China goes to Bhutan and it's like, okay, Bhutan, it's your time to be shift deleted. What can they do? Like, you can have soldiers, but here's the deal. Soldiers have the ability, like let's say USA goes to basically Vietnam and soldiers starts to die. Now here's the deal. Even if your country can handle it, like let's say countries like, bro, we can easily handle 100,000 casualty, but you lose 1,000, here's the deal. Every soldier generally means one family is kaput behind it. So there are way too many people, more than like 1,000 you got kaput there. There is a very good chance you have 5,000 or 6,000 people angry in your own country. That has some serious horsepower. And again, that has horsepower even in communist system. That's why when you look into Soviet Union, that disaster of Afghan war was like so bad. Again, it's classified as like one of the major nails in their coffin. And again, this is a good thing. Now we are almost touching a point where you can just send drone after drone after drone after drone after drone, and you can just shift delete a small country. And nobody in your country will even care because nobody is dying. That happened. That's like we created the pathway for it 2 years ago. That's scary. So this was my presentation on Edge AI. Let's just hope it does not cut us. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.